Neil deGrasse Tyson once said, "We have no idea what it is, but we can measure it." The probe that has traveled the farthest of all time, Explorer 1, has made a surprising discovery. Something returned to Earth that startled scientists. Explorer 1 detected a strange hum coming from outside our solar system. But what is it? Is it a form of matter previously unknown? A signal from extraterrestrials? Or an interstellar quantum phenomenon? We can measure it, but we don't know what it is. Neil deGrasse Tyson expressed both excitement and frustration at the same time. This discovery shocked the scientific community, as no one expected such signals in interstellar space. This discovery was made by Stella Koch, a student at Cornell University. She and her team found the hum in the data from Voyager's plasma wave system, which measures the number of electrons traveling through interstellar space. Although the hum is extremely faint, it repeats so often that scientists think this signal could finally give us important answers about the actual workings of space between the stars. Stella Koch believes the hum could originate from gas interacting with the star's solar wind and magnetic resonance. Did you know there's a slight wind between the stars? We always think of a vast black space as being empty, but that's not true. The hum recorded by Explorer 1 could be caused by the interstellar wind, which is made up of charged particles circulating in the interstellar medium and interacting with the remnants of the solar wind. Or perhaps the signal results from resonance between the magnetic fields of interstellar objects and the probe itself. These resonances could generate vibrations that are perceived as a hum. But now, the conversation has started to focus on what interstellar objects could be. It could be, for example, small miniature meteorites regularly striking the surface of Explorer 1, generating vibrations that are then recorded as a hum. The hum could also be some sort of echo from an ancient stellar explosion that occurred long ago, with its energy and particle waves traveling through the interstellar medium, creating a faint but measurable noise. These remnants of supernovae, which may have happened thousands or millions of years ago, could be an echo of the old cosmos. However, completely new objects in space, which we haven't recognized, could also be conceivable. In this case, the hum would be the first sign of an entirely new discovery. Is Explorer 1 on the trail of an uncommon quantum phenomenon? The Voyager mission is considered one of the most iconic journeys of a human-made measurement instrument of all time. Launched in 1977, the probe has now traveled such a distance that the only radio contact that remains is a marvel. It takes over 22 hours for a signal to reach Earth from the probe's location. If Explorer 1 encounters a strange phenomenon, we only learn about it 22 hours later. However, the strange hum was not directly perceived by scientists. It was isolated from old data, and the signal wouldn't have been discernible from the noise. Special computer programs were able to filter it out from thousands of data points. It is possible that other privileged insights and measurement results are hidden in the data and that we haven't noticed them yet. Some suspect that the hum, or other data that might be hidden, could be evidence of extraterrestrial technology. The hum could come from a distant extraterrestrial technology, sending signals across space. These signals could be a form of communication or even a kind of radar. Once again, there is no official investigation on this matter, only speculation. Other exciting explanations for the mysterious hum in space involve quantum phenomena. Quantum fluctuations occur constantly at the subatomic level, with particles and antiparticles appearing and disappearing spontaneously. These quantum fluctuations generate tiny vibrations, which, although very weak near Explorer 1, could be amplified over long distances and perceived as hums. This idea describes a kind of quantum noise that travels through the interstellar medium. These vibrations could also be amplified by quantum entanglement, a phenomenon in which two or more particles are linked together. This signal truly seems like a mysterious hum from the universe, trying to communicate something that we don't yet understand. Such quantum phenomena might even be portals to hidden aspects or parallel universes. In string theory, which attempts to explain particles and the fundamental forces of the universe, it is assumed that there are extra dimensions beyond our known four. Sometimes these hidden aspects might penetrate into our space-time, causing measurable effects. These penetrations could create energy fluctuations that then translate into a hum in the interstellar medium. There could be portals to these parallel universes that occasionally interact with our own universe. The discovery of such a portal would, of course, be groundbreaking. These ideas are viewed with skepticism by mainstream science, but it is fascinating to open ourselves to such possibilities. So far, however, the official opinion remains that the hum is likely due to an ordinary interaction between the interstellar wind and the solar wind's heliosphere. Voyager 1 is navigating the heliosphere. What no one knows is that Earth does not orbit the Sun directly in space. Instead, we orbit our star in a kind of protective shell that scientists call the heliosphere. Earth does not freely move in space, but it is bound to the Sun, integrated with the other planets, moons, and celestial bodies. Together, they form our solar system, which flies through the galaxy like a closed case. But even the Sun cannot move freely through the galaxy. It is bound by the gravity of other stars in the Milky Way, moving in harmony with them, and ultimately guided by the galaxy's center and other structural impacts. The way our heliosphere moves within the galaxy and the effects or forces it encounters remain one of the great mysteries of cosmology. You can imagine the excitement with which scientists awaited the moment when Voyager 1 crossed the heliosphere on August 25, 2012. The time had come. Voyager 1 crossed the heliosphere, the outer limit of the Sun's sphere of influence, and entered interstellar space. This boundary is known as the heliopause and marks the point where the solar wind, a flow of charged particles, meets the interstellar medium and ceases to propagate. It took nearly a year for scientists to be sure that the transition to interstellar space had truly occurred. The entry was only confirmed in September 2013 in a study published in Science. Scientists were stunned, as they had imagined that the boundary of the Sun's influence would be much more gradual, like water on a beach. Instead, Voyager 1 reported crossing a nearly solid barrier of particles. This skin constitutes the true boundary of our solar system, and the discovery most likely highlights the importance of the heliosphere as a closed shell within the galaxy. Researchers didn't initially know what the exact balance of the heliosphere was, or what marked the start of interstellar space. As Voyager 1 crossed the heliosphere, it recorded several other remarkable changes in its environment. First, the plasma instrument aboard the spacecraft recorded a spectacular increase in plasma density. This event occurred between April 9 and May 22, 2013, when a solar eruption caused nearby electrons to vibrate. These vibrations showed a particle density higher than in areas inside the heliosphere, a clear indicator that Voyager 1 had finally reached interstellar space. Another sign was a significant drop in solar particles and a simultaneous increase in galactic cosmic rays. On the day Voyager 1 officially crossed the heliopause, it reported a decrease of solar particles by 1,000-fold, along with an increase in cosmic rays by about 9%. Finally, the team was encouraged to officially announce the entry of the probe into interstellar space. Another significant clue about how the boundary of our heliosphere is constructed was shown through the differences with Explorer 2. Explorer 2, the twin spacecraft of Explorer 1, crossed the heliosphere on November 5, 2018, about 6 years after Explorer 1. Explorer 2 was equipped with a functional plasma instrument that had failed on Explorer 1. Thanks to these additional plasma measurements, researchers were able to obtain more precise and direct data, which had only been indirectly determined with Explorer 1. It was confirmed that while both probes recorded an increase in plasma density, their measurements of the magnetic field showed clear differences. Explorer 1 did not experience any significant changes in the magnetic field, which was a real shock, while Explorer 2 showed some subtle changes that once again provided exciting clues about the nature of the heliopause. Thanks to this data, scientists can now better reconstruct how our solar system interacts with the surrounding space, its impacts, and how the environment through which we travel with our star is structured. Mainly, Voyager 1 was never meant to return to Earth. You might be surprised to learn that Explorer 1 was never designed to explore an extremely cold and dense environment for over 40 years. The fact that the probes lasted this long and that the technology functioned perfectly is a miracle. NASA is proud of its two veterans, even though the program sometimes faced opposition. Budget cuts in the space program nearly led to the premature end of the mission. But science convincingly showed that we, humans, needed these two probes and the knowledge they provided about space. Operating and maintaining the probes costs hundreds of thousands of dollars, but the results of their measurements and the remarkable position of the two probes in interstellar space are invaluable for research. The probes will continue their journey for a few more years, as long as they remain functional. In 2021, Explorer 1 experienced a dramatic failure, and for months, NASA feared for the continuation of the mission. Some engineers managed to solve the problem, and the mission could proceed. In the spring of 2024, NASA issued another statement saying that the mission would likely end soon. Since the fall of 2023, the probe had been sending cryptic data that no one could read. In April 2024, the miracle was announced again. Voyager 1 emitted signals once more, and the adventure continues.